Section 6.7 is on solving radical equations and inequalities. A radical equation is an equation with a radical expression, and in this case there's going to be a variable in the radicand. So to solve this, we need to isolate the radical, that is, get it all by itself on one side of the equal sign, square both sides, or if necessary, raise it to a power. We'll see that in one of our examples. Algebraically solve for x, and then check. And you must check because sometimes when you square both sides of an equation, you can end up with what's called an extraneous solution, a solution that does not work in the original problem. So let's take a look at several examples here. First one is the square root of x minus 2 minus 1 equals 5. So the first thing we want to do is to isolate the radical. So I'll add 1 to each side. So that gives me the square root of x minus 2 is equal to 6. And now when I square both sides, remember squaring gets rid of the square root sign. I'll have x minus 2 equals 36. Actually, maybe I'll go ahead and write that in here. So what I did was I squared both sides. Okay, and now adding 2 to each side, x equals 38. Okay, and I do need to check that. So let's plug that into the original equation actually. So x is 38 minus 2 is the square root of 38 minus 2 minus 1 equal to 5. Square root of 36 minus 1 equal to 5. Recall that when you check, you do not add or subtract things on both sides of the equal sign. You just PEMDAS each side. So 6 minus 1 is indeed equal to 5. It does check, so my solution is x equals 38. Here's another example that actually has a square root on each side, so I can't isolate the square root. I have the square root of x minus 12 equals 2 minus the square root of x. So in this case, I just have to go ahead and square both sides. And it is going to get a little messy here on the right because what I have to do to this is make sure that I FOIL. Because the stuff inside parentheses, it looks a lot like a binomial. So on the left, it's going to be easy. That's going to give me x minus 12. And over here, if you need to do it on the side, you can do that. But that's going to give me 4 minus 4 times the square root of x plus x. Okay, now I have an equation that has a radical in it, so let's get that all by itself. Let's subtract 4 on both sides and subtract x on both sides. So that's going to give me a negative 16 equals negative 4 square root of x. Dividing both sides by negative 4, I'll get 4 is equal to the square root of x. And now squaring both sides, x equals 16. Now, looks pretty simple, but let's make sure it does work and let's check that. So plugging 16 in there is the square root of 16 minus 12 equal to 2 minus the square root of 16. Is the square root of 4 equal to 2 minus the square root of 4? I'm sorry, not square root of 4, 4. There we go. So is 2 equal to negative 2? It is not. This does not work, so I have no solution for this one. Remember I said sometimes strange things can happen when you square both sides when you have a square root. Okay, example number 3, square root of 7x minus 2 is equal to the square root of x plus 3. I can't isolate the radical, let's just leave them there. Surprisingly, this one's pretty simple because all I have to do is square both sides. Don't have any foiling to do, so that's going to give me 7x minus 2 is equal to x plus 3. Solving this, that's going to give me 6x equals negative 5. I'm sorry, positive 5. 6x equals 5. X equals 5/6. Now, we do have to check this, and this is going to be a little bit of a nasty check. So is 7 times 5/6 minus 2, square root of that whole thing, equal to the square root of 5/6 plus 3. What I would recommend you do is grab your calculator and figure out what's underneath the square root there. When we do that, we get the square root of 23 over 6 Is that equal to the square root of, and when we do this in our calculator, we get 23 over 6. Indeed it is. And so it does check, and x is equal to 5/6. Again, just do this in your calculator. Don't worry about that it's a funny looking answer. You just have to have the same thing on each side of the equal sign. And let's take a look at this example here, number 4. 2 times the quantity x minus 10 raised to the 1/3 power plus 4 equals 0. So the first thing I want to do is, I don't really have a square root in this one, but I do want to isolate the expression that's raised to the rational power. So I want to get x minus 10 to the 1/3 power all by itself. So let's start by subtracting 4 on both sides. And then dividing both sides by 2. Okay, now to get rid of that 1/3 power, I'm going to cube both sides of the equation, because 1/3 cubed is going to give me 1. So that's going to give me x minus 10 equals -2 cubed is -8, or x is equal to 2. So let's go ahead and check that. Is 2 times 2 minus 10 to the 1/3 power plus 4 equal to 0? Is 2 times -8 to the 1/3 power plus 4 equal to 0? Now remember, to the 1/3 power means the cube root. So the cube root of -8 is -2. I know this seems a little tedious, but we need to show all the steps here. So yes, indeed, -4 plus 4 is equal to 0. It does check, so x is equal to 2. Now, radical inequalities are just like radical equations, but there's an inequality, and it has a variable in the radicand. To solve one of these, little bit of an additional step here. If the index is even, so if we're taking the square root, or if it's like raised to the 1/4 power, we need to identify the values for which the radicand is greater than or equal to 0. Remember, if you're taking the square root of something, you can't have a negative number underneath the square root sign. Then we're going to solve algebraically, as we did with an equation, and then we're going to check this by testing values that should and should not work. Let's take a look at an example here. So I have the square root of 3x minus 6 plus 4 is less than or equal to 7. So the first thing I want to do is find values of x, see what restrictions there are on x. So I'm going to say my radicand 3x minus 6 has to be greater than or equal to 0. Remember, that can't be negative. So 3x has to be greater than or equal to 6, or x has to be greater than or equal to 2. And let's just let that sit there for a minute. Now let's go back over here and solve this inequality. So the subtracting 4 from both sides, square root of 3x minus 6 is greater than or equal to 3. Squaring both sides, because it is a square root, gives me 3x minus 6 is less than or equal to 9. Adding 6 to both sides, and then dividing by 3. So x is greater than or equal to 5. So I have these two things here I need to contend with. So x has to be less than or equal to 5 and greater than or equal to 2. So it looks like my answer is going to look something like this. 2 is less than or equal to x, which is less than or equal to 5. Now, to check this, it's a little more complicated than just plugging in a number, because there's a whole set of numbers that would make this inequality true. So I need to choose a number that is actually less than 2, choose a number in between here, in between 2 and 5, and then choose a number that's greater than 5. So to check, I'm going to choose a number that's less than 2. So I'm going to choose x equals 0, and that should not work, because 0 is not between 2 and 5. So let's see what happens. In the original inequality, it's going to give me the square root of 3 times 0 minus 6 plus 4 is that less than or equal to 7? Square root of, that's going to give me the square root of negative 6 plus 4 less than or equal to 7. Well, the square root of negative 6 is a problem. So no, this is not going to work. So it doesn't work. So I'm happy. Let's pick a number that should work. Let's try x equals 3. And this one should work. So when x is 3, back into the original problem. So I have the square root of 12. Oh, I'm sorry, no, 9. I'm sorry, 9 minus 6 square root of 3 plus 4. Is that less than or equal to 7? Well, the square root of 3 is approximately 1.7. So that's going to give me plus 4. That is indeed less than 7. So I'm happy. That should have worked, and it did work. And my last case here, I'm going to choose a number that's greater than 5, and it should not work. I'm going to choose x equals 6, and that should not work. So the square root of 3 times 6 minus 6 plus 4, is that less than or equal to 7? Square root of 12 plus 4 less than or equal to 7. Square root of 12 plus 4 is approximately 7.5. That is not less than or equal to 7. It didn't work. It wasn't supposed to work, and I'm happy. So my final answer is any values that are between and including 2 and 5. So in this section, we took a look at how to solve radical equations and radical inequalities. Key thing, and it's very tedious, is make sure that you do check your solution.